Hello all, my name is Krishnak and welcome to my YouTube channel. So guys, today in this particular video, we are actually going to discuss about the complete roadmap to prepare for NLP, that is natural language processing. Trust me guys, if you follow this technique that I'm actually suggesting you, you will definitely be able to clear interviews very easily with respect to data science. Now, why NLP is important? Because NLP can be used along with machine learning, it can be used along with deep learning. And from the recent survey, it has found out that is when compared to different things that we learn, like machine learning, deep learning, computer vision, right? The task and or use case that involves NLP, right? Usually recruiters are actually looking for that, so there is a whole new demand with respect to natural language processing. So in this video, I'll be showing you the path. Apart from that, I'll also be showing you the playlist from where you actually have to learn natural language processing. So everything will be getting covered. Please make sure that you watch this video till the end. It is very important guys, because natural language processing is pretty much important. In most of my interviews that I have faced in various MNCs, the most favorite topics they used to pick up was from natural language processing. Now in the playlist of the videos that I'll be also showing you guys, there I'll also be showing you from where you can learn the practical part. So make sure that you watch this video till the end. So let's go ahead and try to see what should be the roadmap to prepare for NLP. So I've created this diagram guys, and in this particular diagram, you actually have to follow bottom to top approach. Okay. So from the bottom, I have actually written over here text pre-processing level 1. So what is natural language processing in short? Whenever your data is having words, sentences, or paragraphs, at that time, usually machine learning model or deep learning model will just not be able to understand those text, right? So we need to convert those text into vectors. And there are a lot of different ways to actually convert words into vectors. So with respect to this, initially, whenever you are starting with NLP, first of all, I like to specify all the libraries that you can actually use. With respect to machine learning, there are very good libraries like Spacey and natural language analysis with NLTK. So NLTK library is also there. You can also use this. This is by Stanford, and Spacey also is another library where you'll be able to do many tasks. In deep learning sections, you definitely know the libraries that we can use like PyTorch, Keras, TensorFlow. Apart from that, if you have transformers, right, or BERT, whenever you are implementing something with respect to transformers and BERT, at that time you have something called as Hugging Face library. Okay, and similarly with respect to most of the transformer task or BERT, sentence classification, spam ham, different kind of use cases, there is also a library which is called as K-train. Now you may be thinking, Krish, you have not uploaded many things with respect to BERT. But see guys, I have already uploaded intuitive things with respect to transformers. Okay, now the next part, that is in this coming week, I will be actually covering both BERT and transformers, theoretical part and also the practical part. Theoretical part of transformer is already been completed. For the BERT, I'm just preparing the material so that I'll be able to showcase all the things that we can actually do in BERT. So probably in another 1 week, I'll be able to complete BERT also. Now let's go ahead with respect to this. If you are if you are a starter with respect to data science and your interest is in NLP, that is natural language processing, I think you can follow this bottom top approach, and trust me, once you follow all this particular approach guys, you will be able to clear the interviews easily. So we'll start with text processing level 1. So in this, the major focus will be on, like, whenever you are given a sentences of words, right? How to do tokenization. What is the difference between lemmatization, StopWords? You have lemmatization, you have stemming. So what is the exact difference between stemming and lemmatization? What is StopWords? What is POS? And many more things. So it's this simple text pre-processing that we usually do as soon as we get some kind of data sets which involve text data. So this is what I have actually written with respect to text pre-processing level 1. And please make sure that you understand all these things in this specific way, because in this specific way only I have uploaded all the videos in my natural language processing playlist, which I'll be showing you once I go through this particular diagram. In the next step, after you're comfortable with this, then the next step is focusing on how you can convert words into vectors. Okay, so in the next step, that is text processing level 2, we usually focus how we can actually convert words into vectors. There are various ways, guys, and probably you need to know the maths behind like how we are actually converting word into vectors. Okay, so there are a lot of techniques like one hot encoding. You can actually use something called as bag of words. I've written it over here. You have TFIDF, you have Unigrams, you have Bigrams and Ngrams. Okay, so I probably think you will be able to see over here. I'm just moving beside. Okay, so in this technique, that is text processing level 2, what we do is that we try to convert words into vectors. When we convert word into vectors, then only whenever we send that particular data to our machine learning algorithms, at that time that machine learning algorithm will be able to understand the context of that specific sentence. So in the second step, you need to be very good at bag of words, TFIDF, Unigram, Bigram and Ngrams. Okay, so the second part is done. Now coming to the third part, again still more advanced level of converting your words into vectors. What are the different other techniques? That also you need to be very good at. And remember guys, all these things have been uploaded in my videos. Okay, I'll be showing you that. I've again readjusted all my playlist in natural language processing. I've added videos from deep learning also, where I'll be covering topics of recurrent neural networks and all. So in this third step, we are focusing on some more advanced techniques of converting word into vectors, which is again pretty much important. And this is like the things that we discuss are like Gensim, word to vec, average word to vec. And remember guys, the third level that we go, as we go higher towards the level, you know, the performance, the accuracy increases. So this bag of words TF-IDF that we have, we need to know that, because interviewer may ask you anything, right, in the interview. So if I consider Gensim, word to vec and average word to vec, they usually perform better than bag of words and TF-IDF, because there are some problems with bag of words and TF-IDFs, and the techniques that we use like Unigram, Bigram, you know, we basically use this kind of libraries called as Gensim, word to vec and average word to vec. Then after you complete this, and remember in the initial stage I told you, right, NLP can be used in both machine learning and deep learning. So after you complete this, you have to solve some of the machine learning use cases. In that use cases, suppose if I take as an example sentiment classifier, spam ham classifier, you know, documents classifier. So all this kind of simple use cases can be solved with the help of machine learning algorithms. And the algorithms that we basically use are like naive Bayes classifier and other kind of multinomial naive Bayes classifier for multi-class classification. And again, those practical videos also I have uploaded with respect to in my natural language playlist. So I'll show you that once I finish this. Then coming to the next stage. Now remember, once we are good with it, now we need to move one more step ahead, and this time we will be moving inside deep learning section. In the deep learning, guys, you need to understand how ANN works, what is loss function, what is gradient descent, what is stochastic gradient descent, what are the different types of optimizers, because I have discussed in my playlist like ADA-GRAD optimizer, you have RMS prob optimizer, different types of optimizer. You need to understand how it actually works. That will give you the base of the ANN, CNN, and apart from that, in the recurrent neural network, which is actually more important with respect to natural language processing, those base that you learn will be very important for that itself. So before going ahead with recurrent neural network and understanding how recurrent neural network works, please make sure that you have the basic understanding of deep learning techniques. At least you need to understand what is gradient descent, how does neural network actually work, what are weights, what are hidden layers, how the neuron, what kind of operation actually happens, you know, what are the different types of activation functions, and many more things. Again, all these videos has been uploaded in my playlist. Okay, then you go into the advanced section of recurrent neural network. You understand that how does recurrent neural network work, because if you don't know, guys, recurrent neural network works very well with sequence of data. This is pretty much important that you need to understand. right? So whenever we work with time series data, sequences of data, because whenever we have sentences of words or words of sentences, right, at that time those are coming in sequences, right? So machine learning translation, language translation can be actually done very, very easily. Some of the use cases are chatbots, question answering application. All those things can be easily solved with the help of recurrent neural network, right? So in order to understand that, you have the basic strong with respect to deep learning. Then remember guys, then you have techniques with respect to long short term memory, GRU. They are always, remember guys, as we go from bottom to top, there are some problems in the bottom, so we are going to top. Just think in this specific way. So in recurrent neural networks, you have some kind of problems. Because of that, we basically use LSTM and GRU, right? So I hope you have understood till here, till this particular step. Now when we go one more level up, in this, we are trying to solve some more practical application with the help of recurrent neural network, LSTM or GRU, right? In this, there is a concept which is coming called as word embeddings, right? Word embeddings is pretty much important. Again, it is an efficient way of converting a word into a vector in a specified number of dictionaries. Suppose in a dictionary there are somewhere around 10,000 words. In that, if we really want to efficiently convert each and every word into a vectors, at that time we basically use word embeddings. And here also probably you may be using word to vec also, right? So when you are actually solving use cases with the help of recurrent neural network, LSTM and GRU, you have to actually solve this text pre-processing, that is word embedding, word to vec, right? So it is pretty much important. You cannot skip that. Remember guys, all the steps that I'm actually telling you, I have also prepared in that specific way. So whenever I used to go and give the interview, it was very, very helpful for me. In this specific way, I always was able to remember there was some problems in this, so we have moved into the next level. Just keep this whole diagram in your brain guys. Trust me, it will work out. You will be able to crack the interviews very, very easily. Okay, now after the text pre-processing, again guys, there are some problems with LSTM, some problems with LSTM RNN. So because of that, we use bidirectional LSTM RNN, and then we also use something called as sequence to sequence neural networks like encoders and decoders, and there is also something called as self-attention models. Everything has been covered in my playlist with theoretical understanding, with practical intuition. Trust me, you just try to follow in this specific manner, you will be able to understand everything. Okay, so bidirectional LSTM, what is the problem with respect to LSTM recurrent neural? There are some problems with respect to that. Because of that, we are actually using bidirectional LSTM. Let me just give you one example. Suppose in LSTM, right, when you are considering LSTM, suppose if I have long sentences, right, if I have long sentences, sometimes the output from one neuron, one hidden neuron, you will not be able to understand. Suppose if their dependency is there in the last word of that particular sentence. Okay, suppose the context is involved there. So because of that, bidirectional LSTM, what we do is that we have two separate LSTM, and from forward information and backward information will be coming over there. So with respect to that, you just follow my videos that is given in the NLP playlist. Again, I'll go through those videos also. So in bidirectional LSTM, again, there are some problems. So we actually go to encoders and decoders. And in encoders and decoders also, there is a minor problem. So because of that, we go with attention models, and then we go with transformers. See guys, all the intuition till transformers has been completed in my NLP playlist. The BERT part I will be covering this particular week. Okay, within 1 week, I will try to cover it. I will try to upload more practical videos along with theoretical explanation. So finally, when we understand that what is attention model, because in transformers, we basically use something called as self-attention models, right? How transformers actually work, I've taken 1 hour live session for this. Again, that video also I had added in that particular playlist. Okay, then finally we get to know about BERT. Remember, BERT is nothing but it is a variation of transformer. Okay, it is a variation of transformer, and this BERT over here, you understand, in word to vec what we did, we try to convert a word into a vectors. In BERT, we actually convert a sentence into a vector. Okay, this will be pretty much amazing when you are actually learning this, when I'll be teaching you, when I'll be uploading a lot of videos with respect to BERT also. Okay, so this is how you should actually go. So you have started, you have completed tokenization, stemming, lemmatization, StopWords. Then you went with bag of words where you need to convert word into vectors. Then you went with some advanced techniques like Gensim, word to vec. Then you solved machine learning use cases. You got the understanding of the basic deep learning techniques where you have understood about how does the neural network work. You have understood about loss function, optimizers, various kind of optimizers, different kinds of stochastic gradient descent or gradient descent or different kind of gradient descent you have understood. Then you went to understand about RNN, because why? Because you are actually dealing with, whenever your input is having sequences of data, you're dealing with recurrent neural network. Then there is something called as text pre-processing level at 3, where you are actually performing word embeddings or word to vec. Then you have bidirectional LSTM, RNN, encoders and decoders, along with the self-attention model. This self-attention model is actually used in transformers. There are a lot of advantages with respect to transformers. Then again, BERT is again a simplified version of transformer where you're solving some more extreme complex problems, right? And as I said, the libraries that you can actually use is PyTorch, Keras and TensorFlow. You have Spacey and NLTK. Also, in my playlist, I've actually completed with NLTK, with Keras and PyTorch playlist also I'm actually preparing it. But at least Keras and TensorFlow is more than sufficient. Okay, now this was with respect to the whole diagram. You have to follow bottom to top. Please make sure that you take the screenshot, keep it in your desk, so that whenever you see the screenshot, whenever you're going for the interviews, just for revision technique, you can actually go through this, right? Now coming to my playlist, how you should follow these particular videos. So what I've done is that, guys, I've created 2 dedicated playlists. One is natural language processing and one is complete deep learning. So first of all, you see this. I've started with tokenization, stemming, lemmatization. So stemming, practical intuition. This is lemmatization, practical intuition. It is, right? This is theoretical intuition. So you can also see bag of words intuition, bag of word practical implementation, TFIDF intuition, TFIDF practical implementation, then some machine learning use cases. Then we went to word to vec, then again some machine learning use cases. Here also machine learning use cases, machine learning use cases. Okay. Then after this, what we do is that I think I forgot to add one, that is RNN over here. I think somewhere it may be getting added, but don't worry, I'll add RNN over here. After this, RNN video will be uploaded, not directly bidirectional RNN. Don't go with that. First of all, try to learn RNN. Then you can see word embedding I have added. Then you have bidirectional RNN. Then you have Keras fake news classify using LSTM RNN. So everything has been covered. You can see why use recurrent. Oh, so I had actually put it over here. So let me just move it over here, okay, for you all, so that you will be able to find it out. So everything I'm moving over here. Back propagation in RNN, right? Back propagation in neural network. Then some problems in recurrent neural network. So I have added everything in order now. So okay, yeah, LSTM. Okay, so this will be in my 32 tutorial, 34 tutorial. Okay, perfect. LSTM, recurrent neural network, in-depth intuition. That I have bidirectional RNN, in-depth intuition. I'll put this bidirectional after at least one project. Okay, yeah, here. Okay, so here you can see that I've put this in order. Tutorial 29, why use recurrent neural network? Recurrent neural network, forward propagation with time, backward propagation in recurrent neural network, problems in simple recurrent neural network. Then there were some problems in RNN, so I've actually discussed about LSTM. Then we discussed about word embedding, then how to implement word embedding using Keras, you know, Kaggle fake news classifier using LSTM. This use case I've actually solved. Stock price prediction and forecasting using stacked LSTM. So this is what I have actually also focused on. Then again, there were some problems again with LSTM, which you will be able to see over here. And then because of that, I have uploaded bidirectional, then sequence to sequence, encoder and decoder tutorial, practical implementation, problems in the encoder and decoder. Then again, we have attention models, then finally transformers in depth architecture understanding. After this, BERT 1 session will be there, and 7 to 8 use cases I'll be doing on BERT, so that whole practical part will get over. Now, suppose if you are having problem in understanding about deep learning, just follow my complete deep learning playlist, guys. And these videos that you will be seeing over here, whatever deep learning videos I've added over here, it is also present in this deep learning playlist. So here you can see problems with encoder, decoder, sequence to sequence learning, implement fake news classifier using bidirectional LSTM, bidirectional RNN intuition. So what I'm going to do is that I'm just also going to add this in this particular playlist, that is natural language processing. So I hope you have got this particular idea, guys. It's all that you just have to follow this bottom to top, catch that particular video from NLP playlist, keep on understanding, keep on reading, because I have covered both theoretical and practical intuition. Okay, so please make sure that you just follow this, guys. Trust me, I'll guarantee you, you will ace any data science interview. Now, with respect to interview, natural language processing, many companies are actually working in it. If I talk about machine learning, deep learning, if I talk about computer vision, right? Natural language will be always in the top priority. Then you have computer vision, then you have deep learning, then you have machine learning, this kind of techniques. Okay, so please make sure that you start preparing for this, and NLP can be used, learn in such a way that you will be able to use this with machine learning also, with deep learning also, right? So I hope you like this particular video. Please do subscribe the channel if you are not already subscribed, guys. And you can also subscribe my AI Tech News channel. The link will be given in the description. So yes, this is all from my side. I hope you like this video. I'll see you all in the next video. Have a great day ahead. Thank you one and all. Bye bye.